So I want you to close your eyes for just a second.
Okay.
Picture a really massive, just incredibly ornate lecture hall.
Yeah.
It is 1613. We are in the Republic of Venice, specifically at the University of Padua.
Right.
And this place, I mean, this is essentially the Harvard or the Oxford or the MIT of the 17th century.
Ah.
The wood in the room is dark. The air probably smells like, beeswax and old parchment.
Yeah.
And the room is just completely packed. Students are everywhere. They're murmuring. They're waiting.
It's a really high-stakes environment, too. You have to remember, you've got students from all over Europe in that room. German princes, Polish nobility, the sons of Italian merchants. They are there to learn from the absolute best.
Exactly. And for the last 18 years, the absolute best has been a guy named Galileo Galilei.
Yeah.
He is the rock star. He's the man who, just a few years prior to this, pointed a telescope at the sky and realized that Jupiter has moons, that the moon has mountains, that the Milky Way is literally made of individual stars. He didn't just teach the curriculum, he completely revolutionized the entire subject.
He was a celebrity in the truest, most modern sense of the word. He was charismatic, he was incredibly controversial, and because of all that, he filled the seats.
But now he's gone.
Right.
He got a better offer. The Medici family down in Florence offered him a position as the court mathematician, which meant more money, absolutely no teaching duties, and full freedom to just do his research. So he packed up his lenses and his loot, and he left.
Leaving just a massive gaping vacuum behind him at Padua.
A vacuum that somebody has to fill. So I want you to imagine you were the guy they hired to replace him.
Oh, man.
You have to walk into that specific lecture hall, stand behind Galileo's actual podium, look out at this sea of students who basically worship the ground Galileo walked on, and say, all right, everyone, settle down. I'm the new guy.
That is the literal definition of a tough gig. That is just professional suicide waiting to happen.
It really is. And today, we are doing a deep dive into the life of the man who actually took that job. His name was Giovanni Camillo Glorioso. And if you were out there scratching your head thinking, I have never heard of this person in my life, you are definitely not alone.
Not at all.
History just has this way of putting all the spotlights on the massive revolutionaries and leaving the people who have to come in and clean up after them entirely in the dark.
Which is really a shame, because Glorioso wasn't just some substitute teacher keeping the seat warm. He was a titan in his own right. He was this incredibly rigorous mathematician, a brilliant observational astronomer, and as we are definitely going to find out today, a man with a very, very short fuse.
Oh, the fuse. We are absolutely going to talk about that fuse, because this deep dive isn't just going to be about math equations and dry star charts. It is about the scientific blood sports of the 1600s.
Blood sport is exactly the right word for it. I mean, we tend to romanticize this era. We think of it as this time of polite discourse, right? Gentlemen scholars sipping wine and quietly discussing the cosmos.
Right, very civilized.
But the reality was so much grittier than that. It was a time of incredibly vicious pamphlets, wild accusations of plagiarism, and these deeply personal feuds that lasted until one of the participants died, and in some cases even continued after they were dead.
Yeah, we have a stack of sources here to go through that are honestly just wild. We have letters, we have these scientific treatises with titles that literally sound like death metal albums. We have the actual mathematical proofs that help force the transition from the Middle Ages into the modern scientific era.
Our mission today is to essentially resurrect Giovanni Camillo Glorioso for you. We want to see this incredibly volatile world through his eyes, the eyes of the successor. We want to understand what it actually takes to hold your ground when you are standing in the shadow of a giant like Galileo.
Right.
And we really want to unpack how the truth of science is actually forged. It's not just these neat little eureka moments. It is decades of arguing, checking the math, and dealing with colleagues you absolutely cannot stand.
So let's strip away the Galileo mythos for a minute and look at the man who followed him. Where does a guy like Glorioso even come from? What is the origin story of the person brave enough, or maybe crazy enough, to replace Galileo?
To really understand Glorioso, you have to mentally map out Italy in the late 16th century. He was born in 1572, way down in the Kingdom of Naples.
Now, Kingdom of Naples sounds very grand, but we're talking about the deep south of Italy, right?
We are. Specifically, he was born in a small place called Montecorvino Ravella. It's near Salerno. So he is very far removed from these bustling northern power centers like Venice or Florence. He was a southern Italian boy growing up in an era where those regional differences dictate almost everything about your prospects.
In 1572, that puts him squarely in this weird generation that straddles the very old world and the brand new one.
Exactly. He is only 8 years younger than Galileo, so they are effectively contemporaries. But Glorioso is just slightly behind the curve chronologically, which means he is coming of age in a world that is already starting to crack open intellectually. The old rules are just starting to show some stress fractures.
Well, let's talk about how he was educated, because looking at his resume and the sources, he did not start out as a math prodigy.
No, and almost nobody did back then. You didn't just go off to the university to become a scientist. That word didn't even exist yet.
Right, natural philosophy was the closest thing.
Exactly. So Glorioso actually earned his initial degrees in philosophy and theology from the University of Naples.
Why was that the standard prerequisite? Why not just jump into the numbers?
Because before you could measure the physical world, you had to understand what the physical world fundamentally was. Philosophy provided the absolute framework, which was almost entirely Aristotelian physics at that point, and theology provided the why.
The ultimate cause.
Right. The mindset was that you had to understand the creator's intent before you had any business looking at the creation's mechanics. If you just jumped straight to math without that deep philosophical grounding, you were viewed as just a calculator. You were a technician, not a true scholar.
Okay, so he gets the foundational degrees. He knows his Aristotle inside and out. He knows the theology. But then he takes a hard pivot.
He does. He enters the orbit of the Jesuits. He studied mathematics specifically at the Jesuit College in Naples, and he trained under two really key figures there, Vincenzo Filiucci and Giovanni Giacomo.
We really need to pause on the Jesuits for a second here, because when we hear the word Jesuit today, we might just think of a specific Catholic religious order, maybe high schools or universities. But in the 1600s, in the context of science and math, what did it mean to be trained by the Jesuits?
It meant you were dealing with the absolute intellectual special forces of the era. The Jesuits were the undisputed educational elite of the Catholic world. They utilized this curriculum called the Ratio Studiorum, and it was incredibly, brutally rigorous.
Especially in the sciences.
Yes. In mathematics specifically, they were strict followers of Christopher Clavius.
Clavius, he's the guy who basically fixed the calendar, right?
Exactly. He was the architect of the Gregorian calendar that the entire world uses today. And the Jesuit mathematical tradition that Clavius built was completely obsessed with precision. They focused heavily on Euclidean geometry and absolute watertight logical proof.
So no guessing.
None. They despised hand-waving. They didn't like vague poetic theories about how the universe might work. They demanded mathematical rigor. So if you studied with the Jesuits, like Glorioso did, you came out with a brain that was essentially wired to find errors. You were trained to spot the flaw in someone else's logic.
That feels like a totally crucial character trait for Glorioso. He is basically trained from the ground up to be a debugger of the universe.
Debugger is the perfect way to put it. He is a debugger. And that specific intellectual training totally sets the stage for his future interactions with a guy like Galileo.
So how did the two of them actually cross paths initially? Is it like a fan meeting his idol?
Not really, no. It was much more of a peer-to-peer dynamic. You have to remember the scientific community in Italy at this time was tiny. It was a very small club.
Right.
Everyone wrote letters to everyone else. Glorioso was already part of this respected mathematical circle that included guys like Marino Gottaldi and Antonio Santini. These are very serious, heavy-hitting mathematicians. So Glorioso and Galileo corresponded. They were friendly enough. Glorioso was very much in the club.
So the powers that be at Padua, they know who he is. He's a known quantity. He's smart. He has the theological credentials, and he has that intense Jesuit mathematical rigor.
Right. And then comes 1613, the great pivot point.
Galileo takes the posh job in Florence. The chair of mathematics at Padua suddenly opens up.
And we cannot overstate this. The chair of mathematics at Padua was arguably the most prestigious academic post for a mathematician anywhere in Europe at the time. Padua was under the direct protection of the Republic of Venice. It was wealthy, it was powerful, and crucially, it was slightly more secular and independent than the rest of Italy.
So you could push the envelope a little bit more there.
Exactly. It was a known safe haven for free thinkers. Well, up to a point, anyway.
And what about the compensation?
The salary was actually quite significant, even though Galileo was famous for constantly complaining that it wasn't enough. But the prestige, that was the real currency. To be the mathematics professor at Padua was to be the undisputed voice of authority.
So the university makes Glorioso the offer. He accepts it, he leaves the south, and moves up north to Venice.
He takes the chair.
I really want to circle back to the psychological aspect of this, though. Because Galileo was, at his core, a massive showman.
Oh, absolutely.
He intentionally wrote his dialogues in vernacular Italian so the common merchants could read them, not just the Latin-speaking elites. He cracked jokes. He was incredibly charismatic. Glorioso, based on his Jesuit background, sounds like he was much more, I don't know, by the book.
He was entirely by the book, and honestly, I think that is the exact reason he survived the transition.
What do you mean?
Well, if he had walked into that lecture hall and tried to play the role of Galileo 2.0, he would have failed miserably. You simply cannot out-charisma a generational celebrity. The students would have eaten him alive. Instead, Glorioso did a hard pivot to pure, unadulterated competence.
He leaned into the math.
Exactly. He positioned himself as the very serious, highly rigorous academic who wasn't going to try and dazzle you with optical magic tricks, but who was going to teach you the absolute unbreakable truth of geometry.
So he was the eat your vegetables professor compared to Galileo's dessert-first approach.
In a lot of ways, yes. But we also have to remember he was stepping into an active war zone. By 1613, the conflict between the traditional Aristotelian view of the universe and the new telescopic observations was getting incredibly hot, and Glorioso walked right into the dead center of it.
And he clearly didn't just keep his head down and teach the syllabus. He got straight to work. Let's dig into his actual astronomy, because the outline from our sources points to a very specific event that really defined his early tenure at Padua, and that is the Great Comet of 1618.
This was just a massive culture-stopping event. Late in the year 1618, 3 different comets appeared in the sky in succession, and the third one was absolutely spectacular. It was huge, it was incredibly bright, and it was visible for weeks on end. Literally everyone saw it.
Kings, peasants, the Pope.
Everyone.
And naturally, because it's the 17th century, everyone immediately starts arguing about what it actually is.
Right, and to fully grasp why this was such a bitter argument, we have to do a very quick crash course in Aristotelian cosmology.
Please lay it on us.
Okay, so Aristotle's physics had basically ruled the intellectual world for 2,000 years at this point, and his system states that the universe is strictly divided into 2 distinct zones. Zone 1 is everything below the orbit of the moon. They called this the sublunar sphere. This includes the Earth, our oceans, and our atmosphere. And Aristotle said this entire zone is made up of 4 elements: earth, water, air, and fire.
The classic 4.
Right. And the key feature of Zone 1 is that it is fundamentally imperfect. Things down here change, they grow, they die, they rot, they burn, they decay. Chaos and unpredictable change are perfectly allowed in the sublunar zone.
Got it. Zone 1 is messy and mortal.
Exactly. Now, Zone 2 is everything above the moon itself, the sun, the planets, the fixed stars. Aristotle insisted that the superlunar zone is completely different. It is made of a mysterious 5th element called the quintessence.
And what's the rule for the quintessence?
The rule is perfection. This material is crystalline, it is flawless, and most importantly, it is completely immutable.
Immutable meaning it literally never changes, ever.
Never. The heavens are eternal. They operate like perfect, frictionless clockwork. According to this physics, nothing new can ever be created up there, and nothing that is up there can ever be destroyed.
Okay, so suddenly, enter the Great Comet of 1618.
Right. Here is this giant blazing streak of fire that just appears completely out of nowhere, moves erratically across the sky, visibly changes its shape over several weeks, and then completely vanishes.
If you are a strict Aristotelian professor whose entire career is based on the heavens being unchanging, that comet is your absolute worst nightmare.
It breaks the entire system, because if that comet is actually up in the heavens, then the heavens are actively changing. And if the heavens are changing, Aristotle is fundamentally wrong. And if Aristotle is wrong about physics, the entire theological mapping of the universe that the church has built up over centuries starts to collapse.
The stakes are just incredibly high. So what did the Aristotelians actually say to defend themselves? Did they just say, don't look up?
They basically said, oh, it's not actually in the heavens at all. They argued very forcefully that comets were just weird atmospheric phenomena. They called them exhalations.
Exhalations.
Yeah. The theory was that they were essentially swamp gas. Just hot, dry earth vapors that rose up from the ground into the very upper atmosphere, but still firmly within Zone 1, the sublunar sphere, and they simply caught fire due to friction.
So they were trying to write off the most spectacular astronomical event of the decade as just some fancy weather?
Exactly. It's just a sublunar fire. It's not a celestial body. Crisis averted.
But Glorioso didn't buy that explanation for a second.
Not for a second. Glorioso was a mathematician. He trusted geometry, not ancient dogma. He, along with a few other forward-thinking astronomers like Tycho Brahe up in Denmark, decided to actually measure the comet's position, and they used a mathematical technique called parallax.
Okay, let's break down parallax for the listener who maybe hasn't thought about high school geometry in a while.
It's actually very intuitive. Hold your thumb out at arm's length right now. Close your left eye and look at where your thumb is relative to the wall behind it.
Okay, doing it.
Now open your left eye and close your right eye. Your thumb appears to jump back and forth across the background, right?
Right, it shifts completely.
Yeah, bring your thumb right up to touch your nose and do the exact same thing. The jump is huge.
Massive jump.
Exactly. But now, look out your window at a building that's a mile away and blink your eyes back and forth. The building doesn't appear to move at all.
Got it. So the closer an object is to you, the more it appears to shift against the background when you look at it from two different angles.
Precisely. So apply that to the comet. If the comet is just swamp gas burning in our local atmosphere, meaning it's very close to the Earth, then astronomers observing it from widely different parts of Europe should see it in significantly different positions against the background of the fixed stars.
Because they represent the two different eyes blinking.
Right. But if the comet is incredibly far away out among the planets in the heavens, then the shift, the parallax, will be practically zero.
So Glorioso actually sat down and crunched these numbers.
He did. He made his own rigorous observations of the comet from Padua. He collected the observational data from other astronomers across Europe. He did the math, and he found no parallax, or at least none that was measurable with their instruments.
Which conclusively means the comet is very, very far away.
It means it is millions of miles away. It is absolutely, without a doubt, in celestial realm. Glorioso laid this all out in a major work published in 1624 called De Cometis Dissertatio Astronomico Physica. He effectively said, look, the geometry does not lie. This object is currently smashing its way right through your supposed immutable crystal spheres.
He was just driving a mathematical stake right through the heart of the Aristotelian universe.
He was. But here is the massive plot twist in all of this. Do you know who famously got the comet issue completely wrong?
Don't tell me.
Oh, yeah. Galileo Galilei.
No way. The guy he replaced. The father of modern astronomy.
The very same. Galileo actually argued that comets might just be weird optical illusions, sort of like rainbows or strange reflections of sunlight hitting atmospheric vapor. Galileo stubbornly refused to accept Tycho Brahe's model of comets as celestial bodies, mostly because he had his own personal beef with Tycho's system. He got completely caught up in his own rhetorical arguments and missed the truth.
That is genuinely fascinating. It really humanizes the history of science.
Yeah.
Just because you're an absolute genius doesn't mean you bat 1,000 on every issue.
Exactly. And it really highlights Glorioso's fierce independence. He didn't just blindly echo whatever Galileo said. He followed the hard data. He was a rigorous to his core. If the parallax calculation says the comet is celestial, then it's celestial, period, regardless of what Aristotle or Galileo thinks.
He was also heavily involved in watching the planets, right? It wasn't just this one comet.
No, he was a very dedicated long-term observer. He became particularly famous for his detailed observations of Mars and Saturn, and we really have to pause and remember what the word observation actually meant back in the 1620s.
It wasn't exactly sitting in a climate-controlled room looking at a computer monitor.
Not even close. You are standing outside on a stone tower in the freezing, damp Padua winter. You are looking through a long, heavy wooden tube fitted with hand-ground glass lenses that probably have tiny bubbles and imperfections in them.
Right.
And you are trying to sketch this tiny, blurry, constantly shivering blob of light by the flickering light of a candle before your hands go completely numb.
It was a test of physical endurance as much as it was intellectual.
It really was, and Glorioso did the hard, unglamorous work night after night. This just reinforces the reality that he wasn't just a theorist sitting in an armchair. He was a working, practicing astronomer.
Let's shift gears a little bit and talk about his other major superpower, which was math. The source outline explicitly calls him one of the leading Italian algebraists of his time. Now, I know listening to two people talk about 17th century algebra on a deep dive is usually a guaranteed cure for insomnia, but there is actually something incredibly cool here about the evolution of the language of math.
It is incredibly cool because the way we do math today, the basic symbols we take completely for granted, they basically didn't exist yet. Or at least they were just in the painful process of being born.
Right, like today, if I want to write down, say, a to the power of 8, I just write the letter A and I put a tiny little 8 right next to it. Boom, 2 characters, I'm done.
It's simple, it's efficient, it's universal, but in the early 1600s, algebra was still desperately trying to transition away from what historians call a rhetorical style.
Rhetorical meaning using words instead of symbols.
Exactly. They wrote out complex mathematical problems in full grammatical sentences. So imagine trying to balance a complex polynomial equation, but you have to write it out like you are writing a paragraph of prose in an essay.
The unknown thing multiplied by itself, which is then added to the unknown thing cubed, is equal to the number 10.
Yes. It was incredibly, maddeningly cumbersome. And the biggest problem was that it made it almost impossible to visually spot the underlying patterns because you were just drowning in a sea of Latin words. So the top mathematicians of the era were desperately trying to invent a shorthand, a new code to compress the logic.
And Glorioso was one of the guys writing that code.
He was. His major work in this specific field was called Exercitationum Mathematicarum Decades Tres, which he published in parts between 1627 and 1639. He was aggressively pushing for a standardized, symbolic way to represent massive exponential powers.
Our sources give us a very specific visual example of his notation. And I have to say, looking at it, it looks really weird to modern eyes.
It does look strange. It's the string of letters, capital A, lowercase q, lowercase c, A, Q, Q, C.
QQC. It sounds like someone sneezing, or just a really terrible hand of Scrabble tiles.
It definitely does, but it's actually a very logical, albeit clunky system once you understand the rules he was playing by.
Okay, decode AQQC for us. What does it actually mean?
It literally translates to A to the 8th power.
Okay, so how on earth do you extract the number 8 from the letters QQC?
You have to look at the Latin roots of the words those letters stand for. The Q stands for quadrato, which means squared. The C stands for cubo, which means cubed.
Okay, squared and cubed, 2 and 3.
Right. But the system they were working with involved combining these terms in a hierarchical way to build bigger exponents. So a square QQ would be a variable squared and then squared again.
So x squared times x squared, which is x to the 4th.
Exactly. And then the C term, sometimes referring to cubo or sometimes a related term like census, depending on the exact regional mathematical dialect, would modify that 4th power, effectively multiplying the indices to reach the 8th power. The specific mechanics of how they stacked these abbreviations were varied slightly from mathematician to mathematician, but the core innovation is what matters. Glorioso was systematically stacking these letters to build a much larger number without writing a sentence.
So instead of writing out the unknown quantity multiplied by its own value 8 consecutive times, he just jotted down AQC.
Exactly. It's all about data compression. It allowed him to write these incredibly complex multivariable equations on a single line of paper. It is literally the difference between trying to download a movie on dial-up internet versus using fiber optic broadband. It certainly wasn't perfect. Obviously, our modern exponent notation is vastly superior, but it was a massive, necessary step forward in the evolution of human thought.
It's just amazing to think that somebody actually had to invent the way we physically write math down. We just take it as a given, like the alphabet or the wheel. But a guy like Glorioso had to sit at his desk, look at a massive paragraph of text and say, this is way too slow, we need a better tool.
And by building that better tool, he fundamentally sped up the global rate of scientific discovery. Because if you can write your thoughts faster and you can visually process the equation faster, you can think faster.
He also used his math chops to tackle some of the classic impossible problems of antiquity, right? The outline specifically mentions squaring the circle.
Ah, yes, squaring the circle. This was the absolute white whale of classical geometry.
What is the actual challenge there for the uninitiated?
The challenge, which goes all the way back to the ancient Greeks, is to construct a square that has the exact same area as a given circle, but you are only allowed to use a traditional compass and a straight edge to draw it. No measuring rulers, no protractors, just arcs and straight lines.
And spoiler alert for anyone trying this at home, it is literally impossible.
It is mathematically impossible. We know that for an absolute fact now because the number pi is a transcendental number. You simply cannot construct it geometrically using only those two specific tools. But they did not know that in the 1620s, so brilliant people wasted years, sometimes their entire lives, obsessively trying to solve it.
And there was a guy named Giambattista della Porta who very publicly claimed he had finally done it.
Right. Della Porta was this very famous, very eccentric Neapolitan polymath. He was a bit of a magician, a scientist, a playwright, a real Renaissance man. and he published a work claiming he had successfully squared the circle. And Glorioso, true to form, stepped right in to be the ultimate academic buzzkill.
The ultimate fact-checker strikes again.
Glorioso wrote a blistering refutation. He basically took Della Porta's supposedly perfect proof, tore it apart gear by gear, and showed exactly mathematically where the logic completely failed. He confuted him.
He seems to really enjoy proving other people wrong. Like, it seems to be his primary love language.
I think enjoy is probably an understatement. I think he practically lived for it. Which brings us perfectly to the most dramatic and honestly the most entertaining part of Glorioso's entire life.
Yes. Section 4 of our sources, the beefs.
The scientific blood sports.
You know, we think of scientists today having an argument and maybe they write a slightly passive-aggressive peer review or they subtweet each other. But in the 17th century, they absolutely went for the throat.
It was a full-contact combat sport. Your public reputation was literally everything. If someone attacked your theory in print, they weren't just questioning your math, they were attacking your personal honor, your livelihood, and your basic intelligence. You couldn't just take the high road and let it slide. You had to completely destroy them in the public square.
And Glorioso found his ultimate arch-nemesis in a man named Scipione Chiaramonti.
Chiaramonti. He is either the great villain of this story or the tragic hero, depending entirely on how much sympathy you have for Aristotle. Chiaramonti was a very prominent philosopher from Cesena, and he was the ultimate die-hard defender of the old ways.
He was Team Aristotle all the way to the bitter end.
100%. He fundamentally believed the Earth was the center of everything, that the heavens were immutable crystal, and that comets were just swamp gas. He represented every single thing that Glorioso was trying to mathematically disprove.
So how does this epic feud actually kick off?
It started with a book. Chiaramonti published a major work called De Tribus Novus Stellis, which translates to On the Three New Stars. He was desperately trying to use complex philosophical arguments to explain away the recent supernovae and comets in a way that would somehow save Aristotle's physics.
And Glorioso gets his hands on a copy.
He reads it, and he absolutely hates it. He wrote a formal critique of the book that the historical sources describe as particularly harsh. He didn't just point out that Chiaramonti's math was a little off. He heavily implied that the man was fundamentally incompetent.
Which, obviously, Chiaramonti is not going to take lying down.
Of course not. So Chiaramonti stews on it, does his own writing, and in 1636 he fires back. He publishes a new book specifically targeting Glorioso, titled Examens Censuri Gloriosi.
The examination of Glorioso's censorship.
It sounds a bit dry and bureaucratic to us, but in the context of the time, it was a brutal public takedown. He tried to systematically dismantle Glorioso's mathematical credentials.
Okay, so now it is 1637, round 3 of the heavyweight bout. What does Glorioso do?
He massively escalates. He publishes his own response volume, and he titles it Castigatio Examinis.
Castigatio.
Yes, it translates to the castigation. Or, more directly, the punishment.
The punishment of the examination? That is amazing.
He is literally publicly disciplining Chiaramonti's book. He is treating this respected philosopher like a naughty little schoolboy who completely failed his arithmetic test.
That is just incredibly condescending. I love the pettiness of it.
Oh, it gets so much better. Chiaramonti, seeing that he is now being publicly punished, spends another year writing yet another book. He publishes it in 1638, and he titles it Castigatio Ioannis Camilli Gloriosi.
The punishment of Giovanni Camillo Glorioso. He literally just takes the title and throws it right back in his face.
It is the extremely highbrow 17th century equivalent of saying, "No, you are." But you have to imagine the sheer effort involved here. These are not quick little tweets. These are massive, full-length Latin treatises. They are filled with incredibly complex geometric diagrams and dense logical arguments. They are printed on very expensive paper, painstakingly bound, and distributed via carriage all across Italy. These two men are spending years of their finite lives just to comprehensively insult each other.
It's pure obsession at this point.
It absolutely is. Glorioso tries to finally end it and get the last word in 1641. He publishes a book simply titled Responsio the Response. You get the sense he's just tired of it. He just wants to lay out the final facts and settle the score permanently.
And then what happens?
And then, shortly after that, Glorioso dies. It's 1643.
So, ding, ding, ding. The fight is over. Glorioso rests in peace. The debate is closed.
You would think that. Any normal person would think that. But Scipione Chiaramonti was a man of truly spectacular historical pettiness. He literally waited until Glorioso was safely dead and buried. And then in 1644, a full year after Glorioso's funeral, Chiaramonti published Opus Scipionis Claramontis Citatus de Universo.
Which was what, exactly?
It was a massive 500-page summary of his entire cosmological philosophy, and right in the middle of it, he formally declared total, absolute victory over Glorioso.
He dropped a 500-page brick of a book on a ghost.
He literally declared himself the undisputed winner of the debate solely because his opponent was no longer breathing and therefore couldn't publish a rebuttal. It has to be one of the ultimate cheap shots in the entire history of science.
But, it also really speaks to the sheer desperation of the Aristotelians, doesn't it?
It absolutely does. Chiaramonti wasn't just fighting one Neapolitan mathematician. He was fighting the entire tide of human history. I think he knew, deep down in his bones, that the observational data and the math were irrevocably turning against Aristotle. He could feel the walls of his universe closing in on him, so he just shouted louder. He wrote longer, heavier books. He tried to physically drown out the truth with sheer volume.
It's almost tragic in a way. He spent his entire life fiercely defending a worldview that was already dead.
While Glorioso spent his life building the new worldview, even if he was kind of a jerk about how he did it.
And he wasn't just a jerk to Chiaramonti, right? He had plenty of other feuds going on simultaneously.
Oh, plenty. He fought bitterly with another scholar named Fortunio Lichetti. And weirdly enough, he even picked a massive fight with a Swiss mathematician named Barthélemy Sauvé.
Who was Sauvé?
Sauvé was the guy they hired to replace Glorioso at Padua when Glorioso finally retired.
Wait, hold on. So Glorioso takes the immense pressure of getting the job after Galileo. He holds the chair successfully for years. He finally retires. And then he immediately starts heckling the new guy who took his place.
Yep. In 1630, Glorioso actually published a tract called Responsio ad Vindicius Bartholomew Sauvé. It implies a very serious, very public conflict between them. It seems Glorioso was incredibly territorial. He treated that chair of mathematics at Padua like it was his own personal throne. He simply couldn't stand seeing someone else sit in it, even after he had voluntarily left.
This just paints a picture of such a deeply complicated man. Brilliant, rigorously scientific, incredibly forward-thinking, but also prickly, highly defensive, and maybe just a little bit deeply insecure about his legacy.
I think that's a very fair psychological assessment. But, that insecurity, or maybe we should just call it an absolute obsession with correctness, that specific trait led to some of his most interesting historical moments, which the outline refers to as his hot takes. And this directly involves his famous predecessor, Galileo.
Right, Section 5, the hot takes. Because you would naturally think, having successfully replaced Galileo and survived, Glorioso would be his biggest hype man. Yes, I am proudly following in the massive footsteps of the great, untouchable genius.
But he wasn't at all. Glorioso absolutely refused to be a sycophant. In fact, he actively went out of his way to debunk some of the foundational myths surrounding Galileo's legacy.
There's a very specific letter mentioned in the sources, dated May 29th, 1610.
Right. This is quite early on, a few years before he even took the Padua job. He is writing a private letter to his good friend Johann Schreck. And in this letter, he basically decides to completely fact-check Galileo's entire resume.
What specifically does he go after?
Two major things. First, he goes after the sector.
Explain what the sector is for us.
The sector was a really brilliant physical calculation instrument. Visually, it looked kind of like a compass, two flat metal rulers joined together by a hinge, but it had all these very specific proportional scales and markings engraved along the legs. It was essentially the pocket calculator of the Renaissance.
What did they use it for?
Everything. You could use it to calculate complex compound interest for merchants. You could use it to determine the exact weight and trajectory of artillery cannonballs for the military. You could solve advanced geometric surveying problems. It was an incredibly useful, very highly sought-after tool.
And Galileo was famous for it.
Galileo manufactured them in his own personal workshop. He sold them to wealthy patrons for a premium. He even wrote and published the definitive instruction manual on how to use them. He made a lot of money and built a lot of his early reputation off the sector. But in this letter, Glorioso writes, Galileo did not actually invent this instrument. Michel Coignet did.
Was Glorioso actually right about that?
He was mostly right, yeah. The instrument has a very murky, iterative history. Modern historians usually credit guys like Fabrizio Mordente or Michel Coignet with inventing the early functional versions of the proportional compass. Galileo took their designs, he undeniably improved the engravings, and he brilliantly popularized it, but he did not invent the core concept from scratch. Glorioso was quietly pointing out to his friend that Galileo was taking way too much credit for other people's engineering.
And then in that same letter, he goes for the absolute big one, the telescope.
The holy grail of the scientific revolution, the single device that completely changed humanity's place in the universe. Glorioso flatly tells Schreck in the letter, Galileo did not invent the telescope.
That is just a stunningly bold statement to make about the man who is literally historically synonymous with the telescope.
It's bold, but the crazy thing is, it's absolutely true.
It is true.
We know for an absolute fact now that Dutch spectacle makers, primarily a guy named Hans Lippershey, were openly applying for patents on these magnifying spyglasses in 1608. The technology was already floating around Europe. Galileo just heard a rumor about the Dutch invention. He quickly figured out the underlying optics of how lenses bend light, and he managed to grind much better glass to build a vastly superior version. But he absolutely did not invent the concept of the telescope. He just refined the engineering to a scientific grade.
So why was Glorioso so incredibly pressed about this specific issue? Why act like the ultimate reply guy on Galileo's historical timeline?
I really don't think it was just professional jealousy, though maybe there was a tiny bit of that. I think it loops all the way back to his strict Jesuit training. Glorioso hated imprecision in all its forms, and he especially hated the great man narrative, this romantic idea that one solitary, untouchable genius just invents everything out of thin air while everyone else is asleep. He saw science for what it actually is, a very slow, highly collaborative, cumulative process. He wanted the obscure Belgian scholars and the working-class Dutch opticians to actually get their rightful due in the historical record.
He was aggressively prioritizing factual historical accuracy over hero worship.
Exactly. He was effectively saying, look, Galileo's great, the astronomical observations he made with the tube are amazing and world-changing, but let's not lie to ourselves about where the physical tool actually came from.
It is a surprisingly modern perspective.
Yeah.
It's almost like he is demanding to see Galileo's citations.
He was the original uncompromising peer reviewer. And as we all know, peer reviewers are rarely the most popular people in the room, but they are absolutely necessary for the integrity of the system.
So we have this portrait of a man who just spent his entire life aggressively fighting battles. Battles over the distance of comets, battles over how to write algebra notation, brutal pamphlet wars with stubborn Aristotelians, battles over exactly who gets the patent for the telescope. It just sounds physically and emotionally exhausting.
It must have been completely draining. But the interesting thing is, as he finally reaches the twilight of his life, the tone of his story really shifts. The fighting actually stops.
Let's talk about that legacy, the final years of his life.
Glorioso eventually leaves Padua for good and returns down south to Naples. He goes back home. He is in his late 60s by this point.
Wow.
He is widely considered a deeply respected, albeit incredibly combative, elder statesman of the Italian scientific community.
And he ends up meeting someone important there.
He meets a man named Francesco Fontana. Now, Fontana wasn't a university professor. He was actually a Neapolitan lawyer, but he was completely obsessed with astronomy in his spare time. And he happened to be a very, very talented lens grinder and observer.
Now, based on literally everything we've learned about Glorioso today, I would absolutely expect him to just tear this amateur lawyer apart. Like, your lenses have aberrations, your math is sloppy, get out of my sight.
Right, that is exactly what his track record would suggest. But he didn't do that at all. Glorioso actually befriended Fontana. He actively became his mentor. He constantly encouraged Fontana to pursue his telescopic research. And most importantly, he gave Fontana the absolute keys to the intellectual kingdom.
He gave him full access to his private library.
We really have to stress what that means in context. In 1640, a private scientific library was pure, unadulterated power. Printed books were rare, they were astronomically expensive, and they were hard to transport. Scientific data was not something you could just look up online. It was physically locked inside these heavy, letter-bound volumes. And Glorioso's personal library contained the accumulated knowledge of his entire, incredibly dense career. His private letters, his annotated treatises, rare observational manuscripts from guys like Tycho Brahe and Johannes Kepler.
Giving a younger amateur astronomer free access to that collection, that is a staggeringly huge deal.
It is the ultimate act of scientific generosity. It is Glorioso implicitly saying, I am finally done fighting. I have done all the math I can do. I want you to take all of this hard-won knowledge and go further into the dark than I ever did.
It really shows that underneath that incredibly prickly, defensive exterior, he actually cared about the work itself more than his own ego. He wanted the methodology of science to survive him.
He truly did. Glorioso eventually died in Naples on January 8th, 1643. He was around 70 or 71 years old.
And what actually happened to that incredible library after he was gone?
It was sold off to the Spanish viceroy of Naples, a man named Ramiro Núñez de Guzman, which honestly was probably the best case scenario because having a vastly wealthy and powerful patron acquire it meant the physical books were actually preserved and protected, at least for a while, rather than just being scattered or burned.
So we have reached the end of the life of Giovanni Camillo Glorioso. When you zoom all the way out past the petty pamphlet wars, past the weird archaic algebra, past the comets, what do you actually see? What does a guy like this represent in the grand sweep of history?
I see him as the dark matter of the scientific revolution.
I really like that image. Break that down for us.
When we look back at the history of science, we naturally tend to only look at the brightest stars. Galileo, Isaac Newton, Kepler. They shine incredibly bright and they blind us to everything else. But a galaxy is actually held together by the massive amounts of dark matter that we don't always talk about and rarely even see. Glorioso is that mass. He is the quintessential working scientist. He is the guy quietly doing the unglamorous, tedious verification of the data. He's the one fighting the brutal, exhausting rearguard action against the entrenched Aristotelians so that the new ideas can actually take root and survive.
He is the guy in the trenches doing the dirty work.
He absolutely is. He's a perfectly transitional figure. He has one foot stuck firmly in the medieval world, fighting these ridiculously petty Latin pamphlet wars over honor, and he has his other foot stepping boldly into the modern world using advanced algebraic compression and proving through geometry that the heavens are actual, physical, changing places.
He essentially proves that the scientific revolution wasn't just magic. It wasn't just apples falling on heads. It was work. It was a daily, frustrating grind.
And looking at his life leaves us with one final, slightly haunting thought to chew on.
The Chiaramonti feud.
Yes. Think about the timeline there. Glorioso spent decades of his life aggressively arguing for the objective truth. He had the math, he had the observational data, he had the reality of the universe on his side. But simply because he happened to die 1 year too early, his bitterest rival got to write the final word. Chiaramonti published that massive book claiming total victory, and there was absolutely no one left with the specific authority to answer him.
It raises a really massive, slightly uncomfortable question for all of us.
It does. In the grand scheme of human progress, how much of what we accept as historical truth is actually established by the weight of the evidence? And how much is established simply by the sheer biological luck of outliving your opponents?
If Glorioso had just lived 10 more years,
he absolutely would have written the responsio to the responsio. He would have mathematically crushed Chiaramonti once and for all in the public record.
But in the very end, the math still won out. The comets were real. Glorioso was fundamentally right, even if he didn't personally get to write the final chapter of his own story.
That is the ultimate comfort of the scientific method. The individual scientist dies, the massive egos eventually fade away into dust, but the equation itself remains completely true.
Well, on a surprisingly profound note, I think we will wrap up this deep dive into the life of the man who replaced Galileo. A man who reminds all of us to always check our sources, to rigidly respect the data, and maybe, just maybe, to keep our book titles under 10 words.
Please, for the sake of the historians and the librarians, keep it brief.
Thanks for joining us for this deep dive, everyone. We will see you on the next one.
Goodbye.